Wow. Hello and welcome everybody to FineConf 2019. It is so exciting to be here and to present our very first conference dedicated to the Fyne toolkit, its community and all the projects around it. We've got a packed few hours for you coming up today. And well, let's just get started with a little outline of the day to come. The schedule should have been available on the website. We hope that you've had a chance to look at it. We're going to get started shortly with an introduction to Fyne, a reminder of why the project exists, why we think it's important that a project like this is supporting graphical application development in this day, and what is new. After all, we did organise this event around the 1.2 release, and there is a lot of exciting things to share with you. Don't forget at any point during this session that you can tweet questions to us. Do use the FyneConf hashtag if you're wanting us to get notice, and we'll try and answer questions as they come. We also have the YouTube live chat available in the browser, and if you're on one of our Slack channels, then please do talk away there. We have many of the Fyne community available today to help out, and we look forward to answering any questions that you would have and adapting our content to fit that which is going to be interesting for those tens of people who are watching us now. Now, before we get started, I just wanted to say a couple of thank yous to speakers and support that we have available today. My name is Andy Williams. I started the Fyne project last year, and I'll be talking through the welcome presentation, our introduction, getting started, and the what's new section this morning, and then concluding later on today with the release information and our roadmap going forward. Stephen Houston is joining us from the USA. I'm very excited that he is going to share with us in a couple of hours' time the status of our Fyne Desk project and where that is going. So if you're excited about the Linux desktop and a new approach to that, then do stick around. Steve O'Connor, another of our core contributors, has helped put together the presentation on fun and games with Fyne. Unfortunately, he isn't able to join us right now, but we are going to be able to patch in some of his presentation a little bit later on. And also a thank you to Scrivito, a SaaS CMS platform based in Germany, who have kindly sponsored our Q&A session later on today, which will be held on Google Meeting. Everybody is welcome to join us there. It's the only portion that won't be live streamed through Twitter, but anybody who would like to get involved is welcome to do so. Just a quick reminder also, we're going to run the getting started and what's new section, followed by the fun and games. There'll then be a short break for people to catch their breath, and we will follow on with a second live stream URL, which you can find on the website at conf.fyne.io. Excellent. Well, let me take this opportunity there to speak through the vision and the background of the Fyne toolkit for anybody who hasn't caught one of our presentations before. The question that I think it's important to start with is, why do we need a new GUI toolkit at all? Well, there's any number of reasons, but I think these are the top ones that motivated the decision to start this project in the first place. For anybody who's familiar with coding graphical user interfaces, these problems may be familiar. And for anybody who's worked through web technologies or is new to this area, it may not matter quite so much, but these are the main areas that are worth learning from when thinking about how to go forward. A graphical user interface is something that has been around for a very long time, and it has evolved a number of times in that period. However, the toolkits that we have available now, especially on the desktop, are really built on legacy languages and technologies. It doesn't take long before you realize that many even of the newest adaptations are based on a C language project or binding underneath. That may not be obvious initially, and it may not even matter to start with, but after a while you realize that things like the memory management, the thread management, and other aspects of object lifecycle creep through into whichever language you are using on top of it. And so it means that without taking a fresh approach, starting from scratch, you're going to be in a situation that is held back by the choices of many years before. Another challenge that we face is the steep learning curve. It's not as easy to simply write your first graphical application as it is to create your first web page, to perhaps write a command line application, or to put together other applications based on more modern tooling. And so this is a challenge to people getting into graphical application development for the first time. In this area, it would be very beneficial if the tooling and documentation was slick, easy to understand, but unfortunately that's not always the case. Some documentation can be hard to find or hard to read. It may not be integrated into your development environment. And even in the situation where the documentation, examples and tools are fully featured, it may not be straightforward to get them installed. There are certain packages which are so large that your hard drive may struggle to get up and running just to display a Hello World application and understand the code underneath it. And all of those said, it's still exceptionally difficult to well support multiple platforms. A lot of the better technologies and toolkits around at the moment target specifically one or two platforms due either to their similar nature in terms of the hardware or because of the commercial aspects. One company may be pushing one platform and they would like integration across devices on the platform, but not quite so much for anything outside that ecosystem. And so even with technologies that are capable of cross-platform deployment, it may not be as simple as we know it could be. And so thinking about all of these elements and looking at the landscape of what was available, it was decided that there was a real opportunity here for a brand new toolkit that could address these concerns and make the graphical user interface landscape a lot more approachable. We hoped that by taking this avenue, it may become a lot more easy to build applications for desktop and for mobile. That would mean that even the very beginners would be much more able to write their applications and distribute them. And also, this is an opportunity to show that application development native on desktop and mobile is capable of being built quickly and easily so that we can achieve the speed and ease of use that a native piece of software can without having to adapt it from web technologies or other areas that have perhaps not quite the right design for this piece of software. And if we got it right, maybe we would even see more open source graphical applications out there, either looking really great or just being much easier to get involved with and to improve over time. And so we thought it was time for a new solution, a Fyne solution, if you will. Our aim is to be the best toolkit for easily developing beautiful native graphical applications across all platforms. I think that speaks volumes and encapsulates what we're all about, and everything that we talk about today will tie back to this ambition. And when we say all platforms, we really are going out there to try and reach every platform where a graphical application makes sense. So if your device has a screen, then that is something that we want to be targeting and helping people to build great software for. So what does it look like when this is done well? What does a good toolkit enable? In our opinion, it is really important that such a new technology is self-documenting, so it's really easy to learn, easy for the documentation to be found and understood by anybody who is familiar with the technology, the language, or not. And it needs to be idiomatic with the language it is built using, meaning that everything that it does is consistent with the way that the language is designed, so that libraries built outside of the toolkit will work really well, so that functionality is discoverable and easy to bring in to an application built with the toolkit. We want a clean and simple architecture, something that is no more complicated than it has to be. In fact, all of the difficult aspects of building a graphical application should be well out of the developer's concern. It should be handled completely transparently so they can get on with building their application. Thinking about how it's designed from an end user point of view, we liked the way that the material design was approaching interface design, the recommended approaches, the iconography, the clean palette was very helpful. And of course, the fact that Android users recognize and understand this, and in fact, anybody who uses Google software on the web or iOS as well would be familiar with the design language. And additionally, they have taken an approach to use vector-based graphics, which matched our understanding of how to build a graphical toolkit in the modern age. When using vector graphics, we are able to adapt the user interface to any scale so that we can have a great looking output on small devices with a low pixel count, handheld devices where there's a huge number of pixels, all the way through to perhaps a television where it's a massive screen, but again, the pixels aren't great. If you can scale very efficiently and have beautiful graphics at any resolution, your applications won't suffer on any of the target devices. And also, we wanted to offer both light and dark themes to provide a consistent user experience across all of the applications. So this means that somebody running a Fyne application could decide whether they prefer a light or a dark theme to their desktop or to their applications, and this would match the system configuration, that they have set up on their device, but that whichever they choose, the user experience would be clean, it would be very easy to understand how applications were working, and they would instantly be able to pick up these applications and get to work using the main functionality with no trouble at all. And at a technical level, no runtime dependencies were absolutely critical. There's a lot of good software out there which might require that you install libraries or bundle libraries with your applications, which makes need for installation systems, package managers, and we thought application distribution needs to be so simple that somebody should be able to just copy the application onto their computer and it will work, no matter what system that is. And so those are the principles that we used when designing the Fyne toolkit, and we try to stick to them at all times. There is a widget demo which demonstrates all of the functionality available in the toolkit for anybody who hasn't seen it yet. This is the widget page of the demo. You can get it using the go get command at the top of that page and tab through it yourself. And this also, of course, comes in a light theme as well. And why don't I just load that and we can have a look. Excuse me one moment. There we go. Unfortunately, I had some settings set up that weren't ideal there, and I noticed, unfortunately, the URL here mentioned Fyne settings. It should be Fyne demo. That's a little bit of a spoiler for later on, but we'll check that out shortly. So this is the home screen of the demo app. It's designed to show the capabilities of the toolkit and also as a learning aid. So anybody who was looking to build a Fyne application, if they were struggling at all to find the features that they wanted, well, they could come to this application, see them in use, and then, as with the rest of the toolkit, the source code is readily available. So they could look at the code, how it's utilized, and then be able to incorporate that in their application. So the widget demo here illustrates how each of the pieces of functionality render. We've got buttons, input fields, as you would expect, select boxes, sliders, a variety of progress bars, and there are things that will help to lay out your application, such as the form, scroller, and also an image scroller. If we look at the graphics tab, you can see what's available at a lower level than the widgets. These canvas objects are the drawing primitives that a Fyne driver implements to be able to draw your application to screen. You can use any of these in your application, but as you'll notice, they don't match the theme because they are just basic objects. And the widgets that utilize them apply the theme to them. There is also a selection of icons available from the material design icon set that you're able to use in your application however you would like. And then we can look at some basic window handling. We have dialog boxes, including a progress bar. On the right hand side, we've illustrated how different layouts can set up content for your application, and also it's possible to open different windows, and this one is a fixed size, this one appears centered on a different screen, but there you go. And an advanced tab, if people want to get into more complicated functionality, you can load a custom theme, you can inspect how keys are being handled, and also test out full screen mode, which is excellent when you're not in the middle of presenting. Okay, so that was a run through the functionality of the Fyne toolkit as it exists. I hope that was useful to everybody listening, and if you're familiar with those things, not a problem. I'm hoping that it's been useful to you so far, but let's make a change and head into what's new. After all, I know that a lot of people were excited to see when this 1.2 release would come about. So let's cover what we've been working on in the last few months and are excited to share with you now. Mobile support. It should be no surprise the 1.2 milestone was entitled Mobile Support, and we're very excited to say that it is here. As you can see on this slide, we have 3 images representing the devices that we've added support for. On the left hand side, it is the Fyne demo application running on an iOS device. This screenshot was taken and saved, so that's why the borders aren't round it like it would be in the simulator. And one thing you might notice is that the toolbar from the demo application is on the bottom of the screen. Some of the widgets are deciding that on a mobile device behavior would be slightly different, and so it matches the user's expectation. You might notice also at the top left of the screen there is a burger menu button which would drop down the menu that your application had configured. On the top right of this slide is a screenshot of an Android device, which looks very similar to the iOS one. Obviously, they are both mobile devices, so the Widget toolkit is adapting them very similarly, but you'll notice the padding is different because it's adapting to a slightly different environment. The hardware may have notches on the iOS where perhaps the Android device didn't, and so the application is fitting within the visible space for your device. And then lastly, it may not be a mobile device, but the Raspberry Pi was included in our supported devices for this release. That is due to the nature of the rendering technology. In fact, the Raspberry Pi uses the same graphics stack as the iOS and Android devices, and so we included support there. What you see in that picture is a touchscreen device that was available cheaply from your favorite online store, connected to a Raspberry Pi and the software built and loaded directly on it, and it works perfectly as well. So what does that mean for the tools themselves? How can people use this new functionality? Well, the exciting news is that the code you write is just exactly as it was before. There are no new blocks of code required to check how the device that you're running on is shaped. The toolkit is going to do all of the heavy lifting for you, and your application will just run as expected. We have added a mobile simulation mode as well, which will be very helpful in working on your applications before you even have to worry about packaging for mobile devices. It's in a tag called mobile, and you can simply run that on your existing code base with go run -tags mobile and then your source code, and that will load a mobile simulating window on your desktop. So this is external to the iOS or Android simulators and emulators. This is purely for debugging. It will run in a device that configures itself like a mobile device, and should be a first point of call if you're thinking about working on these new new devices. Also, we have added iOS and Android operating system types for the Fyne package command. If you've not seen the Fyne package command before, no worries at all. We will be exploring it more later. But as you can see in this last command on the slide, packaging an application for your Android device is as simple as using Fyne package-os Android and the files to include. And that will generate an APK file, which you can then install onto your device or could process and upload for distribution. So that is getting your application ready. How might this new functionality be made available if you do want to learn about the device that you're running on? So we have added some new APIs that help to explore device capability. It's not something that we would recommend doing by default because, as I said, we're aiming to have applications that run absolutely perfectly across all of the devices that we support. But if you want to, you're able to find out information about the device. You can look up device information using the find.currentDevice helper function, or if you have a reference to the loaded driver, it has a device function which will return the information that the driver is currently running for. However you get the device value, it will conform to this interface, and so you can inquire as to the orientation of the device, which would be portrait or landscape. Is it mobile, and does it have a keyboard? Now, the definition of a mobile device may be a little obscure, but currently if it's something that you hold in your hand and walk around with, we're calling it a mobile device. So a smartphone, a tablet is, but the Raspberry Pi currently isn't. The has keyboard is probably much more interesting. That is going to return true if a hardware keyboard is available and false otherwise. That becomes very useful if you would like your user interface to adapt to a touchscreen, if you feel there's a benefit to not having to pop a virtual keyboard up, but instead taking touch input yourself. And we'll explore an example of that a little bit later on. Wow, that was mobile, and I hope that we can check it out a little bit more later on. However, that is not all that we've had added in this release. So let me just show a couple of other things that we have added to this update. Custom widgets. So it has always been possible to write your own widgets for extending your application to do things that aren't supported out of the box. But it wasn't really that easy. A lot of code had to be written, and we wanted to make this much more approachable. And so we have added a new type called base widget in the widget package, and that will handle all of the basics for you. We'll show how that can work later on, but essentially it is taking care of all of the elements of being a widget that aren't specifically the functionality that you might want to be adding. This makes it much more easy to create custom widgets, much less code, and also far fewer potential challenges if this is a new area of code for you. The great benefit to this is actually it makes it much easier to extend existing widgets. Now, there have been a lot of feature requests to add functionality to one widget or to another, and we've not always been able to say, absolutely, that's a great idea. Sometimes it sounds like that might be specific to an application context, and so we have said on occasion that's something that you might need to take care of yourself. And so in this situation, we're making it much more straightforward to build on the widgets that exist. And examples being where you might want an entry that handles certain keys, or you may want to add certain functionality to an icon, such as tapping it. These are all really straightforward now. There is a new function on the base widget called extend base widget, and if you include that line of code at the beginning of your constructor, then everything should work as you would have hoped. As well as custom widgets, we wanted to provide some storage for your applications. So we've made it possible to do exactly that. To utilize the Preferences API, we're needing a new application instantiation called new with ID. This means that you pass a unique identifier in as the beginning of your application so that it knows how to store preferences uniquely for yourself. This ID might be familiar to people who have programmed iOS or Android before, where you declare your unique namespace, and this would be the same as an application identifier if wherever you were publishing required such information. This functionality is made available through the Preferences function of the application interface, which everybody who has built a Fyne app before will have used. It's the very first line of code is to create your application, and their preferences is available right away. Each type of value that can be stored, which is currently string, boolean, float, and integer, has three functions that you can see on this slide. Using string as an illustration, you have the string function, which gets the value of a stored preference, where key is the identifier for that value for your application. String with fallback is a helpful function if you would like a default value to be provided if none has been set. The first function would return the 0 value, whereas the second would provide the fallback value that you specify. And then lastly, there is the setter, which uses the key that you give to store the value in the second parameter. That is pretty straightforward, but hugely useful for any application that needs to store state but doesn't want to have to manage storage or load additional libraries to do that. Also, we have support for the playground. Now, this is something that people have requested for a while, and we're very excited that it's now possible to render parts of your application in the Go playground. We've provided a new package within the tools package called Playground, and that provides these three methods that you see, which allows you to render a window or a canvas, which is the content of a window, or just any canvas object directly to the Go playground. The last function being the most useful for debugging, you can pass a primitive canvas object like rectangle or text, but more beneficial is that you can pass containers and widgets and parent widgets. They all conform to canvas object, and so the render function will be able to display the contents of all of those in your playground window. And we will come back to that later. Lastly, for the functionality that's been added to the toolkit, we've improved the package and installation process for your development. Just like other Go apps, it's always been possible to run a Fyne application using the standard tooling. Go run myapp.go is just exactly what you're going to expect. It will run your application, load any, show any windows that you've defined, and run like any other. However, this is different when you look at graphical application distribution, because we don't really want to just share a single binary file. It wouldn't have the right icon. It wouldn't necessarily be in a place that application launchers expect it. And so we need to package applications. This will take an icon and various metadata files around and bundle them together. This has been improved in the 1.2 release so that the commands parameters such as icon and data are optional and sensible defaults are provided, so most of the time you don't need to manually specify these parameters. And of course we have added the Android and iOS support into this package command, so as well as packaging for Mac, Windows, Linux using this command, you could create your Android and iOS app bundles as well. And finally, we added a new subcommand called install. If you're on a desktop environment and you would like to have the application you're developing installed into program files or the applications folder, you don't have to do that manually anymore. After packaging, simply call Fyne install and the package, and it will make sure that it is wrapped up with all of the metadata and installed into the correct location for the type of platform you're running on. And that is pretty much the functionality available. However, we have packaged one new application with version 1.2, and that is the settings UI. This bundles with a new global persistence of the settings previously made available through environment variables. So users are now able to specify the theme that they would prefer and how they want the application to scale on their screens through a central location which is saved, and they don't have to worry about managing environment variables anymore. And we will look at the settings application in real life a little while later with some code. But just before we move on, let's not forget the hard work that the team put in to all sorts of extra functionality in this new release, including horizontal scrolling, a vertical display for tab container. We're adding pop-up menus to the entry widget, diagonal gradients which can come in handy. We've also optimized rendering for the desktop apps so that things work a lot quicker. We've squashed lots of bugs, and we have managed to work on some of the memory leaks that were found by some community members following previous releases. This is a big release, and we're really excited to share it with everybody here. Now, that's a lot of talking. I think that it would be great to write some code. Let's have a look at building our first Fyne app. So we're going to build a Hello World application. It may not be particularly inspired, but it really is a great start. And I think that you will agree, this code is pretty straightforward. I think it is one of the shortest Hello World graphical applications for native apps that I've seen. I'm not entirely sure how it could be clearer, but let's work through it and understand the code itself. here we have our editor. So we are going to go through that code line at a time, but first of all we need to open a new file. I'm just going to work from the terminal built into our IDE here. I will move to a temporary storage and create a new project. From here, let's create a new file called ui.go and open that. And here we have our brand new file. As with any Go executable, we need to set it up in the main package. We don't have any need for additional packages here. This is going to be quite a straightforward application. And then we need to set up our entry point, which is the main function. Okay, so we have our Go app that does nothing. So we want to create a new Fyne application, and so we start by calling app.new. And there it will import for us the app package of the Fyne toolkit. This is your entry point into any Fyne application. That package does a lot of clever, complicated work to determine what device you're running on, how applications should be configured, and provides a lot of implementation for the operating system it's going to be running on, which of course is detected at runtime, not during compile. We like to use A for application and W for window. We type it a lot and it's pretty straightforward, so I hope that convention isn't confusing. Let's create a new window. A new window there takes one parameter, the window title. And now that we have a window, we should put something in it. So we will set the content of our window, and that's going to require a canvas object. This time, let's just put a label widget in it. So for that, we use the widget package, which I will just import so that we get our suggestions. With that imported, sorry. We have all of the suggestions available to us. Let's use a label which takes the string content. And so we have created our window, set some content to be a label, and before our application will show anything, we need to show the window. Now, you could call window.show. However, because this is our first window, we need to make sure the application runs as well. Now, we could show the window and then run the application, but let's just call show and run, because that will do both for us. With that loaded, we can go here and go run ui.go. And there we have it. This was our first Fyne application. It has been pretty straightforward and loaded on the first run, which is always great. Now, as with any Go application, you could, instead of running, you could choose to build it so that it could be run over and over again. When I do that, you can see that there is a new file called UI, which is our application, and that can be run directly. Now, I mentioned earlier that every Fyne application supports multiple themes, and I mentioned that we have a new settings application. So let me just bring in our settings app. Now you can see my preference is for a dark theme, but if I choose light instead, our preview there, we apply it and you can see our application with no code at all has updated to the light theme. Additionally, you might notice a scale value. This is a floating point value that represents how big we want the items across our application to be. If it seemed a bit small and we wanted larger text and graphics, we could perhaps say 1.2 and everything grows a little. If you were targeting, for example, a kiosk application or running on a super high definition monitor, you could set it to a value of 2, which is getting pretty large. Or if you would like your windows to be the same size across all of your screens at an appropriate value depending on the density of its display, you could set it to auto, and then it would be consistent as you drag from one screen to another. However, for most systems, they have their own scaling. Mac and Windows certainly do a really great job of setting this up, so a value of 1 makes sense for most people, especially during development. And I'm just going to pop that back to dark because that is my preference. Lastly, I mentioned that we have a new simulator for mobile, so we could go run tags mobile UI.go, and that is going to load our application in a very different configuration. Don't worry about the output messages there. There are pieces of work ongoing in the Go compiler that make mobile work better. And here you can see a portrait mobile device simulated in a regular window. It's chosen the light theme because mobile devices have a different way of determining which theme they should use. It's not a global preference that Fyne would save. It is defined by the operating system, and more often they go with light by default, so that too is what we've done. There isn't really a lot to present there, but hopefully that mode will be very helpful for you. Now, if I jump back to our presentation here, we have explored the Hello World example. We have seen that it is really straightforward, a simple app with minimal code. We're able to build it or run it, and it will adapt to the built-in themes, the user's preference, and the scale of the output device, or again, the user's preference. And we have seen it simulated in mobile as well. Now, let us move on, and we could see this working in the playground. We can largely use the same code again, but we do need this playground tool to be able to show the content. Now, if I can bring up the Go playground here, this is a local version of the playground that I'm running. This will work on the regular playground. There's nothing special about the code that I'm running here, except that it is hooked into the Fyne release that is not yet publicly available, and so that's why I'm having to run it locally. As you can see, this is again a widget, a label widget, which we can set to contain hello Fyne Conf. And the new package that we saw in the slide here, the tools playground package, is used here to render this widget. So if I click run and let it build the app for streaming through to the playground, we should be able to see the same content as we would expect in a window. And there you go. It's using the same dark mode that we saw in our applications by default, and it has taken the content, saved it into a format that the browser can view, and streamed it back as a result of the compilation. Hopefully this will be very helpful when learning about code, layouts, or how to set up your widgets, and you don't want to run an entire application every time, but also you don't want to write a new small application just to accommodate the test that you're working on. I think that I will leave the playground there. Any object widget that works in a Fyne app will be able to be rendered here, but I don't think we need to go through every one of them to show that. And whilst we're writing our Hello World application, we could package it for installation or for distribution on another platform, and also we could install it. So let us look at this new functionality as well. So we have our Hello application again, and that's going to be possible to package using the Fyne command. Now, I've previously installed the Fyne command using this command at the top of the slide. Go get the Fyne command. So we could run that, but it's not necessary here. And that's fetching the Fyne command from the Fyne repository on GitHub. But I will just use it here like this. Fyne package this project. And we're seeing, like I said before, that the defaults are being used if you don't specify specifically which icon you would like to use. So we could use a specific file like that, or I could copy a file in. Now, why don't I just copy the Fyne logo? So we can now this may be an issue with the modules configuration. Apologies. Well, in a situation where the package doesn't do what you're expecting, and this does sometimes happen with small one-off projects, we can build it apologies, and then package it. Now you can see I have a new folder called hello.app. So if I open this in containing folder, you can see that corresponds with this icon here. And if I double click the icon, there you go, it's running our application. Very exciting. And if you wanted to go one step further and install it, you can see there's currently no Hello application installed. But using Fyne install, the Hello application appears in our application launcher. How exciting! And if I load an alternative target, so let's say we wanted to package for Android instead. The same command is going to go away and build our software for the Android platform and produce an APK file. Now I will leave that be. It's probably got a lot of code to work through, and we'll come back to it later. Sometimes the compilation of an application can be slow. This will usually just be the first time that you compile for a new target operating system. And I was about to move on, but I can see that it has in fact already completed. We have our hello.apk file there ready for distribution to your Android device, in which case you would use the Android debug bridge to install hello.apk onto your Android device. Now, I happen to have an Android device plugged in, and it is now letting me log on to the phone. And if I just switch over to my camera, I can show you this is our Hello World application that we just built, now running on our Android device. Wasn't that straightforward. And you'll find that building for iOS is almost exactly the same, with the additional step of certification, which means you need to sign up for the Android developer for the Apple developer account and get a certificate to be able to build 4 devices. So we won't step through that right now. Oh goodness. Apologies. So there we ran through packaging. I was going to talk about writing tests as well, but unfortunately that is us really on our time limit. But I'll leave this code on screen just briefly to show that unit testing with Fyne really is as straightforward as unit testing any other Go application, and highly recommended. We start a new test case. In this instance, I've created an imaginary application called a greeter, which would have an entry, that's a text input field, a button, which I've called welcome, and when you type your name in and tap welcome, an output would be to say hello, your name, and our unit test here is able to say type the word name into our entry, tap the button, and then check that the text is hello name. If it's not, then the test should fail. That's pretty straightforward, can be run using the standard Go tools, and is going to execute and test the application in memory without running anything on the screen, which means it's very fast and very easy to run. And cross-compiling is perhaps useful if you don't have tools for building to all different architectures on your desktop. Now, this might be the case if you don't have Mac binaries, the Xcode SDK installed on your Linux or your Windows device. As we're building graphical applications, these are required to build and not necessarily straightforward to install on lots of different platforms. So the Fyne Cross project was created by Luca, one of our core contributors, and this means that you can run builds for platforms that you don't have the tools for locally using a combination of Docker images and installed compilers. If you're thinking about building for lots of different platforms and you don't have the tools yourself, I would highly recommend checking out that project. And with that, I think we have wrapped up our getting started. I will potentially talk more about extending and creating custom widgets a little bit later on. But I think it's probably time for some fun and games. If anybody has joined us for this second segment, welcome, thanks very much. I hope that the getting started and introduction was very helpful, especially if people haven't used the Fyne project before, and it was really great to share with you the new functionality that we're creating and delivering as part of the 1.2 release. And so we come to the fun and games portion of our schedule. This was originally going to be presented by Steve O'Connor. Unfortunately, he's had to deal with certain emergencies at his end, including, I understand, running away from bushfires or dealing with the fallout. And so it's not been possible for him to find an internet connection to live stream his presentation. However, I hope that I can fill in a couple of the gaps, and by kind permission of the GopherCon Australia group, it's going to be possible to share with you some video footage that he recorded a couple of weeks ago at the Australian GopherCon. So with that, I thought it would be really useful just to step in and look at the examples repository, because this has a lot of different functionality embedded in small and fun little applications that can be really helpful if you're looking to understand some of the more complicated functionality. So let me bring up the examples application. Now, this can be downloaded and installed locally if you would like to play around with it on your own computer. Go get github.com/fyne-io/examples. We'll download, compile and install this application on your computer. Of course, you could get the code yourself and run Fyne install if you would like it to be in your application launcher like that. But otherwise, this will install it to your command line and you can use the examples command to load it. So I thought it would be helpful just to look at some of these. As you can see, it's grouped into two sections. We have Canvas applications on the left and widget applications on the right. You may be able to guess the difference. Yes, on the left, these are applications that use only the built-in Canvas primitives, so that is lines, circles, text, rectangles and images and gradients as well. But they are going to look exactly the same irrespective of theme, because they are determining how to draw in their code directly. And on the right hand side we have some widget examples, these are built with the standard widgets for the most part and are going to change their look and feel based on the theme settings. So here is the clock application. As you can see, it is using the circle and line, and it is also going to scale appropriately for our window size. Those elements are placed by a layout routine, which can be explored if you look at the clock example code. But otherwise, it is a background Go routine, making sure that the UI updates every second. The hand does use the primary color from the theme, just to blend in. In fact, the application itself is designed to look like it is built with widgets, and in fact that's possible for any code that you want to build, but using custom colors you can also use the theme colors and adapt when a theme changes if you wish. I also would like to show the solitaire application. This is an interesting application because it showed us just how difficult it is to really efficiently render lots of vector graphics to a screen. When you start working on large desktop screens, there is a lot of pixels to be filling in. And so we spent some time looking at how to optimize the output, the caching, and the rendering so that such an interface would always feel performant. We can apply transparency, move objects around, all just completely smoothly as you would expect. And these, being vector graphics, will adapt to whatever screen resolution it is that you're drawing at. Okay, so let's have a look at the widget-based applications. The calculator here, it is pretty straightforward, does exactly what you would expect for a calculator, and doesn't need any code to handle how these buttons should look. It is simply packing standard widgets into a container. And so if we bring back our settings application here, you can see that changing the theme is going to change the calculator, and you might notice the clock has updated as well as we put some code in to handle that. And then similarly we could choose to scale the applications, and it's all going to update as you would expect. The interesting additional element for the calculator is that it shows how we can take keyboard input without having an input field. So your application can listen for certain input. So here I am typing and hitting enter. And so you could see it has simulated the button presses. And in fact, if you look at the code for the calculator application, it also contains unit tests that demonstrate that if the certain buttons were pressed, then the right output is evaluated. And also I will show the text editor. This for a while was our standard code for getting started slides. It's everything that you would need to start a basic application there. It has a toolbar, you can reset the content, and these values at the bottom are updating each time the content of the entry changes. This is quite interesting both for the layout, and also it is introducing background changes to content, and you can simply update these on a callback, and then the application will refresh to show the result. This application is using the border layout, which we skimmed over when looking at the demo application, and it is saying that the toolbar should always be at the top, the status bar should always be at the bottom, and our entry widget should fill the middle. Now, that is our examples application. I didn't cover all of the applications in there because Steve did a fantastic job of showing how some of these can work, and so with the permission of the kind people at Gophercon Australia, I'd like to play you an excerpt from his video.
So let's say we have a frame buffer device with, say, 64 pixels in a square, and we want to animate that using Conway's Game of Life rules. That's one of the example applications. The code behind that now, we'll look at the animation loop. So we have here a simple go routine, fires off a ticker. We're pulling from the ticker channel 6 times a second, and then down the bottom here, generate the next iteration of the screen, and then widget.refresh. That's very simple code. It's using standard Go tooling. It's using all the good bits like Go routines and channels. And you'll notice here we're actually painting from inside of a Go routine. And if you've ever done any graphics programming, you'll quickly realise that they have this affinity to the main thread. So trying to do a separate thread over here that's painting to the screen is problematic. That's all covered within the Fyne toolkit. We've taken care of all the multi-threading problems that you may have with other toolkits. A little bit of code there. That just shows what we're doing internally to take the current data set on the board and generate the next frame in the Game of Life program. It's just looping through XY coordinates. If there are 2 or 3 neighbour cells that are populated, then that cell stays alive. Otherwise it clears it, and then we just set that into the buffer. Quickly jump to the next one. This is a custom draw routine that we're attaching to a custom widget. So you can write one of these that will return a standard Go image.image, and then you can put whatever functions you like in there to get data out of the current state you've got, use standard Go functions to generate a new image and return that. Fyne will then take the image that you've returned and worry about blitting that onto the screen in the correct main thread and everything else. Okay, quick demo. Over here we have the examples application that comes bundled with Fyne. There's a number of different little toys and tools there with all the code behind that you can dig into and see examples for how to do various things. We'll have a look at life. So here's our little program that we just looked at a second ago. That's doing an animation loop 6 times a second, taking that frame buffer information and blasting it out onto the screen. And again, there's one function there that is needed for your custom widget, which creates a standard Go image structure and returns that. We'll have a look at one other one while we're in here. This demonstrates a different way of doing custom widgets. This is your standard Mandelbrot set. So with this custom widget here, this takes a different type of function that takes an X and Y coordinate and returns a colour that is represented at that pixel. So if you create a custom widget using that fractal method there, what Fyne will do is every time a repaint is required, it'll iterate through every pixel within the display, calling your custom function to get the colour that needs to go in that image. So for example, if I scale that one up, if if I just drag the window, that'll cause a repaint on that window. So when I release the button here, Fyne will then go off, ask your program what the colour value should be at every single X and Y, and then it will just repaint. And it's quite quick. Got some keys here so we can zoom in and have a look around. Performance is pretty good considering how much work is going on there and how simple the code is in your custom widget to achieve that. Make sense? Okay, let's quit out of this. Quit. So a small recap on that. Basically using all of the good bits of Go, all of the hard bits are hidden away by the toolkit and you can get in there and start hacking away very, very quickly. Okay. Conf has come up with a tricky one here. With that particular life program, we did spend a couple of weeks on that one online working out a lot of memory leaks, buffer overflows, and there was some very, very tricky data race conditions happening in there. So when we got to the end of that little project and optimised that so that it was working very nicely with little code, we were saying on a Friday night, wouldn't it be cool if we could just plug a basic interpreter into that and turn it into a retro gaming console? Because it's the same concept where you have a simple frame buffer of 60 by 60 pixels, and you just want to be able to address those from code. So on Friday night, we had a look around and sure enough found that someone had written a basic interpreter in Go. So then finished off my beer and got coding, and by the end of the weekend, we each came up with a very separate implementation using those tools. The approach I took was to write a virtual machine emulator in Go. That probably sounds a little bit overwhelming, but it was actually very simple. It's basically just mapping a frame buffer, creating an animation loop, and then loading in the basic interpreter to run some instructions. Over on the right-hand side here, there's an example basic program that will animate a bouncing ball bouncing around the screen and off the walls and everything. In order to hook that into the virtual machine emulator that I wrote, I had to extend the basic interpreter to enable the program to read and write into the frame buffer, give it a way of getting input via a key interrupt, and then generating a vertical sync interrupt here to tell the basic program that the animation cycle is complete and it can go and paint a new screen. That's a lot of words, but over on the right, there's the basic program to do that. And this is just using off-the-shelf stuff that we found on a weekend, so. Okay, let's see if we can run that. Gopher wants to have a play. So there's our little virtual machine running the basic program, doing a physics engine to animate a ball floating around. And there wasn't really that much code on there to do that. All of the code is again linked on the on GitHub. Thank you, that's really cool. And if I move the keys around, I can interact with that ball to push a vector on there and make it bounce in different ways. And if I hit the escape button, that powers it off. We've even got static emulation on there, and up it comes again. So that was a very small program, and that was something we knocked out on the weekend. It's good fun. Oh, we have a friend. He wants a game for 2 players. Okay then, let's try it again. Here we go, same concept. We've got the same emulator. We've just written a little basic program that will emulate the good old Pong game, using VI keys to manipulate the paddles, of course, as you do. So there we go. I can never win at this thing. So that entire thing took me probably up to Saturday night. while that was happening, Andy in the UK, he lives in Scotland, went off and did something very similar, using the same tools, but to come up with, whoops, something quite different. He wrote a BBC Micro emulator that you can program yourself. And everyone's first basic program, if you can remember this one. Oh no. Live coding. Love it. Hello. Oh, that'll do. Ta-da! So yeah, good fun. So what I'm trying to get at here is that Go is a real compiler, so you can write real programs with it very quickly. There's no messing around with hairballs of JavaScript. There's no messing around with trying to get the right link libraries in C to not completely take up your entire weekend. And more importantly, Go is such a good language that you can hop on the internet, find really cool and weird things that are written in Go, and after a short read and a beer, you can understand what they're trying to do and how to get in there and change it. And maybe even hack what they've done to change it around and interface it with your own silly ideas. And it's all easy and it's all good and it's all very robust. You should do it.
Thanks, Steve. That was really cool. Now, I'm going to continue the fun and games with another example. A little bit of 8-bit fun. Now, if anybody has been watching the cool projects in the Go community, they might have seen a Game Boy emulator before by HF04. He did a really fantastic job of writing the entire emulator, decoding the ROMs, and running in a bitmap window. But we thought, actually, maybe we could take it one step further and bring the Game Boy into something that looked more like a Game Boy. So to do this, we wrote a simple application that loads the bitmap content, applies an image filter over the top, and then put it inside a layout which draws a border around it. Pretty straightforward, but it really adds a nice little touch. And so, like the examples that Steve was showing earlier, this is bitmapped pixels frame buffer inside a scalable application context. So if I just switch out of full screen here and bring a demo in, I'll show you what that means. Let's start with everybody's favorite, a little bit of Tetris. Let's see if I can get a line. Okay, that might be my worst beginning to a game of Tetris yet, but we can take that up to full screen and you can see the vector graphic portions are looking really great and the application is still continuing at a good speed. And this game is really not going well. Surely live coding is preferable to live gaming. Before I do any worse on that, I'm just going to quit that demo. And instead, for a little bit more animation, if anybody likes a good title sequence, this has to be my favorite. The Legend of Zelda: Link's Awakening? Oh yes. In pretty much full screen. And that is probably enough of that. I'll get carried away and I'm sure there's some copyright issues there as well. So that was a look at the, hey, this is really fun side of things. And it absolutely is. I encourage you to go and check it out. What we see on the right hand side, I should also add, is how this could look when you load it on a mobile device. Now, this is a screenshot of the work in progress. It hasn't been pushed to the main repository, but based on what I was saying earlier, you can imagine that this is happening when the application realizes it's running on a device with no keyboard and it's in the portrait mode. So what it's doing is it's laying out buttons, 8 of them, that are going to receive touch input like any other button, and it will use those to generate the codes that the keyboard would have been doing for the desktop application version that we saw before. And hopefully this will be available shortly after the 1.2 release, and we'll be able to show that running on mobile devices very soon as well. Now, that is all very fun, and thanks again, Steve, for running through that exciting part of frame buffer manipulation. And I mean, the BBC emulators just were hours of fun. I'm so excited that you found that project. But what about work? This is not a toolkit that was purely put together for entertainment. We all want to enjoy what we're doing, but sometimes that needs to be work. And so I wanted to talk a little bit about, could you use the Fyne toolkit in your work day to day for the projects that you have to deliver, that your business depends upon? And well, I mean, the answer to that is absolutely yes, people are doing that. I was looking to have some speakers come on and talk about the applications that they're developing. Unfortunately, naturally, they're closed, not open source applications have largely been in a current development stage. That means they're not available to talk about, or in fact they are developing really solid back-end applications that we're never going to be able to see. However, we'll work something out for the next conference, I'm sure. So back to Fyne. How can you rely on this in your day-to-day? Well, this project has been around now over 18 months. It's been growing steadily and has a really solid basis for any of your application development. Our 1.0 release was back in March this year. That represented a significant amount of development, but still showed us there was a very long way to go. There was a very interesting discussion on Hacker News where they suggested that 1.0 might be a bit of a risky approach, and they suspected that APIs would be broken and the applications wouldn't continue to compile. Well, thankfully we're able to say that they were wrong about that, and that our APIs have remained compatible throughout. 1.2 is the first release that introduces some things close to needing a little bit of code altering, but really that is only going to apply to custom widgets that have been created before, and we did discuss this with people that unfortunately to do this right would require a little bit of change. That said, of course, any applications that you build are going to continue to work no matter what, because like any Go applications, these are compiled binaries that work independently of the toolkit that they were built with initially. Since 1.0, we have had another 4 releases. 1.01 helped to address some challenges that were raised after the 1.0 release as we rolled it out for the first time to public consumption. And then 1.1 added some really cool functionality, some new widgets. It's when we saw shadows and some hover effects being added, and it became something that was a little bit more alive and felt more responsive than the first release, which was perhaps a little static in its presentation. And since then, we have had 1.1.1 and 1.1.2, which have each had added some bug fixes, some optimizations, and some small pieces of functionality contributed from people around the world. Those releases have been spread relatively evenly across that period of time. So there's always a new release somewhere soon. If a bug fix is absolutely critical, we can pull that forward. And if we're collecting improvements or functionality that is less critical to the running of existing applications, we might push that out and create a bigger release, such as the 1.2 that we're talking about today. Talking about the contributions coming in, GitHub reports that we now have 30 contributors, and that's on the master branch, so I'm quite certain this is many more now. That we've had great help from people coming in for this new release, including as well as a lot of developers, which you can find named in the commit log or the contributors list. Also, we've had help on graphic design from ASCII Face Man and Storm, who really helped put together the animation and the logo that you've seen so far today. But also we've had testers and people contributing documentation literally from all around the world, which is really fantastic. And if your business isn't ready to rely on a purely open source project, then we're also really happy to be able to offer commercial support for companies that need a piece of paper or a contract. And you can find more information on the support page on our website, which is there, fyne.io/support.html. That's pretty much why we think this works in a business context. And whilst I can't really hand over to people who've been using it in their businesses, there are some projects that I thought it might be nice to share to illustrate how that's already helping people. So if you're in networking, OpenSnitch might be something that you're used to. And this project here, again by Luca, one of our core contributors, put together an interface quite some time ago just to show how easy it was to bring an otherwise less usable application together quickly on the Fyne toolkit. You can get the application from the URL at the top there. Using the go get command will install it to your command line, or you could download it and build and then install using the Fyne install application command I showed earlier. So that's something that just shows that you can put any utility that is a bit of a pain to use into a nice graphical interface. But what about something that is more intensely graphical? Well, it was an idea that was suggested to me by a doctor that imaging applications are either expensive or very slow or don't support the applications, the devices that doctors carry with them day to day. It's sitting on a Windows desktop or a Mac desktop in their office somewhere. Could we bring that to mobile devices, to portable devices, and could we do it using open source technologies and therefore offering it at a very good cost? Yes, as you can see from the image here. The picture is of a simple Fyne application that was put together one day. Literally, it took less than a day. The images are decoded from the DICOM standard. Thankfully, as Steve was saying earlier, there are lots of great libraries out there, and somebody had written a library to decode the file format, which was really great. We loaded an application, the buttons, a simple layout defined down the left-hand side, and the image content was given most of the screen real estate. As you can see, there are we're currently showing, frame 83 of 128, and so you're able to tap up and down through different slices of this medical image. This is all happening efficiently and in real time on a Raspberry Pi, which is plugged into the side just off the shot, and this screen is a touchscreen device that was purchased very cheaply but works very well indeed for such an application. And so we were able to show how a portable or platform agnostic viewer application could be put together on hardware that cost less than $100, and the software was basically free. That is available through the GitHub account of one of our commercial partners, although it hasn't been published on their account yet. The link will come soon after this conference is finished up. And so that is a couple of applications that we have seen out in the wild that maybe we've been working on. But how would somebody know where these applications are, or is there a showcase or something like that? Well, it's fantastic that you asked. We are indeed collecting all of the freely available open source apps that are built on the Fyne toolkit. We are always looking for new entries in here. It's a very varied list, as you can see if you visit this link. Let me just load that here. And so this is the current version of the Fyne apps site. There is a reference to that viewer that I was just showing you, and to the OpenSnitch project. A couple of favorites that you will have seen earlier in this presentation. And there's a couple of other items that might look less familiar. This is a place to come and find the details of any of the projects that you're interested in. And it shows you screenshots, it gives you the appropriate information to download and try them yourself. Now, this list is definitely not complete, as we've been busy working on our release and also on pulling together this conference. It's got a little bit out of date. Applications are being written all the time, and we're excited to see what comes along next. If you know of an application that should be listed in here, you'd be very welcome to open a pull request on our apps.fyne.io repository in GitHub, where if the pull request is approved, it will appear directly on that site, and others will be able to find it too. Shortly, there will also be an integration for installing those applications much more easily than following links and executing commands yourself, and we'll be happy to share more about that later this year. So I hope that that presentation has really excited you about what's possible and what's easy with the Fyne toolkit, the variety of applications, games, and also just random projects that could have a new lease of life using the Fyne framework. So if you would like to know more and get involved, that would be completely amazing. We have lots of documentation available. Like I said earlier, it's really important to us that the documentation is readily available, easy to understand, and not just presented in the browser, but the IDE, as illustrated with the Hello World, is able to pick up this and make sensible suggestions as well. The first link on this slide shows documentation for developers. If you want to know more about the project or how it was designed or how you can use it out with the API documentation, that is a place to go. If you would like to actually make some contributions to the project, you should go to our GitHub account and find the Fyne project. Other projects are there, and you'll hear more about them later today, but for now you could go there. We have guidelines for contribution. It's where we manage all of our milestones and tickets. We have marked things that would be easy to start with if you're new, or areas of particular interest such as a Windows set of tickets, or if you're working on iOS, we have some highlighted that you could get involved in there. And as well as the Twitter handle and the live chat that we've had available today, there is always the Fyne channel on the Gophers Slack server. If you're not on there, then feel free to get an invite. It's in the footer of the Fyne.io pages. The Gophers Slack server is really for all sorts of chat about the Go language, and they are really a great community for asking questions or posing ideas. It's kindly sponsored by Google, I believe, so it's a full account with archives, so you can find lots of great information there. And in fact, we feel very lucky that Go as a language is so well supported. It's suited our needs from a programming point of view, but the community also is fantastic. So that brings us to the end of the first half of our presentations. I will just check to see if there are any questions that we should answer before going on our break. I see some really great chat about those game presentations. Thanks so much for contributing that, Steve. I know that folk got a kick out of seeing those projects coming to life. And I'll just check our notifications. I think that is probably everything, unless people have any last minute questions they would like to ask. And I'll hold on just a few moments for the stream lag. We will continue in 25 minutes with the second half of our conference. The link for the live stream will change. We're going to close the stream, save it so that it could be published, and we'll start a new one which is in the link on this slide. It's also referenced at conf.fyne.io if you can't read or type out this link. And in between the two halves, please do continue to ask questions or to tweet out with the FyneConf hashtag. And if we're not able to answer those questions in the next presentation, we'll come back to them in the Q&A session at the end of the event. In case anybody wasn't clear about how that's going to work, we're opening a Google meeting which is sponsored, as I mentioned earlier, and there will be an open invitation for anybody to join in, ask questions. That part won't be live streamed, but you're more than welcome to come and join us over there. But that is later today. I will join you in just 25 minutes for part 2, where we're going to be handing over to Stephen Houston, who's going to be presenting about the Fyne desktop project. So a little change of speed there, and hopefully we will see you then. Thank you very much, everybody, and see you later.